All right, we're back. This is page 12 of Notes 4. It's the last page of Notes 4 of Calc C, at least. So let's see if we can do it. These are all basically review problems, so I'm going to go through them a little quicker, I guess. I don't know, maybe not. But let's see if we can. So the function f of x is defined by this summation, which is a very normal thing to do. It doesn't feel normal at first, but it's actually a normal thing to do. And this looks geometric to me. And it looks geometric, so I'm going to say f of x is geometric with r equal to whatever's being raised to the n, so this, right? So it's going to converge, therefore converges for the absolute value of x plus 3 over 2 less than 1, which is the same as the absolute value of x plus 3 less than 2. So I like to think of that as -3 is the center, and you can go 2 in either direction. So you got to stay within 2 of that. So -1, -5. So therefore, -5 to -1. So that's the interval of convergence. So on that interval, this f of x converges to a particular function. We need to find the function though. So that's the next part. So what function does it converge to? So g of x is going to be, so it's the first term over 1 minus the ratio. So the first term is when you take n equals 0 and you sub it in. So that gives you 1 over 1. So the first term is just 1 over 1 minus, the ratio is x plus 3 over 2. Okay, so maybe you simplify this. So what on earth does that give you? That gives you 2 over, so I get 2 minus x minus 3. That's annoying. 2 minus x minus 3. -1 minus x. So I'm going to say that's -2 over 1 plus x, I guess. And then we have to say that's only when you're on the interval of convergence. So I'm going to say that is my answer. And then I'm going to check that on the calculator in a second when I actually do the next part. So use your calculator, find the volume of the solid form by rotating f of x about the x-axis on the interval from -4 to -2, which is in the interval of convergence. So that's good. So that's going to be pi, the integral from -4 to -2 of g of x squared dx. And we'll get that. Using your calculator, find the average value of f of x on, okay, so that's going to be the integral, so from -4 to -2 of f of x, which is the same as g of x on the interval, over -2 minus -4. So the integral over the interval, and we will get a value for that. So let's go to the calculator and see how we did. Well, I don't know what it means to see how we did. I'm going to graph them both and see what happens. That's how you see how you did. So f of x, I'm going to say is, so you run into that problem where you can't really put infinity as the upper bound. I mean, you can, but just it basically doesn't really work. So does it not work? Let's see. X plus 3 squared 2 to the n. It's like I say such confident things and then I'm not sure. Nope. Okay, I mean, it worked, maybe. What's f of, what's in the interval? F of -2. Ooh, what? F of -4. Okay, so I guess it does work. What's going to happen when I try to graph that? Let's see. Worst case scenario, it crashes the calculator. I don't know. I don't know how it's doing what it's doing or what it's doing. But that seems to have worked. So good. Let's not look. So what are we doing here? G of x. I was going to say, let's not look a gift horse in the mouth. What's x? I think that has something to do with the fact that you can tell how old a horse is by looking at its mouth or something like that. So let's graph g of x. Ooh, dead on the interval, right? So we only really care about -5 to -1. And then, I mean, I guess the function itself is actually only positive on that interval. So like, let's make it -2 to 17-ish. And here, there's actually two functions here. Look at that, pretty good. Although the interval seems a bit off, maybe. Can I trace, let's see, menu. Let's trace to negative. So the center, there's always a problem with the center, and I don't really know why. -4, undefined. So I don't know what it's doing. I don't know why f of -4 here works, but then on the graph it's not there. I don't know, some complicated thing. But anyway, it looks like we got it right. So so I'm going to assume we did. Pi times the integral of, so you should use the template for this. G of x squared, x goes from -4 to -2. Is there an exact, oh, 8 pi over 3. I'm just going to write, I'm going to use the exact value. So I'm back on the notes. I'm handwriting this. 8 pi over 3. So the average value is going to be the integral from -4 to -2 over the interval, which is -2 minus -4. We just, ooh, natural, interesting, natural log of 3. That makes sense. We didn't need a calculator for that. We didn't need a calculator for either of those, actually, but luckily I wrote the problem so it said to use a calculator. All right, so some weird stuff going on with this f of x definition that like seems, it works on the calculator page. It seems to mostly work on the graph page, but then the interval of convergence like doesn't work on the whole interval for some reason. I don't know. Let's go back and see what the next question is. Then we'll be done with these notes, and that's kind of exciting. These were, I don't know. I hope that as I record these, it turns out that these are long, because I feel like I've been doing this set of notes forever, but we'll see. Differential equation dt dw is -1/4 quantity t minus 76. So there's the independent variable, as you look at this problem, the independent variable is w. There is no independent variable on the right-hand side, which means definitely we're doing separation of variables. Measures rate of change of temperature T in degrees Fahrenheit with respect to the amount of water W in gallons in a tank. Okay. When W is 50 gallons, T is equal to 85 degrees. I don't know if that, I guess maybe that's practical. I don't know. Sometimes I just make them up. I don't know. Write the equation line tangent to T of W at W equals 50. All right, so my ordered pair is 50, 85, and then dt dw. So this ordered pair is W, T, right? Temperature is a function of water. So dt dw such that, I guess, T equals 85 is going to be -1/4 of 85 minus 76, which is -9/4. All right, so what variables should we use? I go back and forth on this all the time. It's like if you're putting it on a set of axes that look like W and T, then the variables that we use should be W and T, right? It should be, so the tangent line should be T minus 85 is -9/4 the quantity. W is the independent variable, minus 50. I believe that's what we should use. I think people use X and Y all the time, and I don't really think you're penalized for that, except like X and Y don't really belong on the same set of axes as T and W, so like, I don't really know. All right, use your tangent line to approximate T of 52. So T of 52 is approximately 85 minus 9/4 of 52 minus 50, which is 85 minus 9/2. 9/2 is 4.5, so I'm going to say 80.5. This is in degrees Fahrenheit because it's a T value. Solve the separable differential equation to find T of W. All right, so let's do this. dt dw is -1/4 the quantity T minus 76. All right, so separate and integrate. There was a year, I tell this story a lot in a lot of the videos in class all the time. There was a year where there's a differential equation like this. Some people came back and they're like, I didn't know how to do it because there was no independent variable where blah, blah, blah. It's just like, ooh, killing me. So this, we're going to separate, we're going to integrate. So dt, T minus 76 negative 1/4 dw. So on this side, we'll get natural log absolute value t minus 76 negative 1/4 w plus c. So I'm going to exponentiate and simultaneously get rid of the absolute value. I'm going to do a lot of one step here. So t minus 76 is a new c e to the negative 1/4 w. I highly recommend you watch the videos if you don't know what I'm doing there. I'm skipping several steps that I always skip. Then we definitely know this ordered pair, which will let us, I was going to duplicate. This ordered pair will let us solve for c. So let's see, that's going to be positive 9. What are you doing, man? 9 equals c e to the negative 50 over 4, 25 over 2. I'm going to go with 12.5. I don't really like doing that, but like, I don't know. So I get 9 over e to the negative, so I'm just going to make that 9 e to the positive 12.5. And then that means that t as a function of w is 76 plus 9 e to the, so it's e to the 12.5 times e to the negative 1/4 w. I'm going to make that e to the 12.5 minus, I'm going to go with 0.25 because I'm living in that like fraction world now. So that I think that this is the solution. So I'll check this, partly just to show you that you can, and also to make sure that we got it right. But let's see what the calculator does with this. So we go over to the calculator and differential equation solver. So menu for and up, up, up. So menu for D really, or you could, well, you can type DE solve, but like on the CX2, there's this wizard that pops up, which is super useful. So here, I'm going to say that T prime equals negative 1/4 and then T minus 76. And then the independent variable is W. The dependent variable is T. And then we have an initial condition that T of 50 is equal to 85. And then I'm going to press enter, and it just fills this in. So if you have a non-CX2, you have to type that in. Either way, you're going to be fine. Press enter, and we get, so it like does everything with fractions, and we chose to use decimals because I kind of like wimped out on that. But anyway, that's the answer that we got. So good job to us. All right, let's go back, and we are done with notes 4. Super exciting. I don't actually know what's in notes 5, but it's going to be new. Probably, I mean, it's definitely a new series test. So we know geometric, we know telescoping, we know nth term test for divergence, and then we did a bunch of practice. So it's actually a lot of stuff in these notes. So I don't know, make sure you know it, and I will see you in the next video.